So 3, 2, 1, go. Lights off. So hi everybody, and I just wanted to do this quick video announcement of the imminent release of the new Terrain System's second version, which makes it a good deal bit faster, and for the rest, well, it's the same thing. And it's essentially a fusion of the simplified Terrain system algorithm and the classic new Terrain system algorithm. The enhancement essentially consists in the fact that between two steps of the adjustment of level of detail in this variant of the algorithm, this very algorithm, much fewer, as few as possible, nearly as few as possible, blocks are operated, that is, added or deleted between two different distributions of level of detail as possible. And this adds great lot of speed and hence lightness to the procedure, because, as we know, can you see it? The performance of this algorithm is moment please. It's proportional. It's linear, which is already a very rare thing in the scenario of algorithms, especially in algorithms which deal with high complexity rendering, such as this, that is surface, real-time surface rendering, polygonal approximation, and even worse, variable level of detail, view-dependent rendering, and so on. But this is linear, but there is to the linearity, which where the number of operations are proportional to the total number of blocks, which here tend to oscillate between 100 and 4,000, but in the worst case could be 6,000. But in other places I have in the documentation said how to handle this to be comprised between 100 and 4,000 or 3,000 blocks. And to this linear dependence there is added an dependence of the kind n multiplied by the n of logarithm n, where n is the number that says how many blocks are added or removed, that is, you could say, are heavily operated between one step of rendering, that is one distribution of the level of detail, and the other. Other things are obvious consequences. Further feature added here is a fast local height retrieval. In fact, you can see that I added, to illustrate how to use this functionality, the fact that the camera cannot go below the level of the surface. This uses quadrisection and so is very fast. It's an ideally fast algorithm for this purpose. So have a lot of fun with this. Remember that this algorithm relies only minimally on the graphical hardware, since it's always used at most around 6,000 triangles, which is a ridiculous number of polygons in a scenario, while does everything procedurally, that is, loads everything on processor, and in this respect it's probability only serious full view distance rendering system of this kind. as you know, the Flightcraft 3D, the return game is made with this. Here I set the view distance to full. This test is being done with an 8000 by 8000 data set, Terrain, and the release proposes a 4000 by 4000 to make the file size of the height field moderate. So enjoy, and clearly, to make this a bit less impersonal, this is a sort of Happy Christmas present as well. So enjoy. It's going to be live in a couple of hours as soon as the loading goes fine on SourceForge. Project is called New Terrain and 3D Map System, and the same variants are proposed as for the previous release. A single thread version, a multi-thread version, a version which has trees and a network of roads on the terrain, a context in which the fast local height retrieval procedure is especially useful, and one where there are vehicles on the terrain. And the simplified terrain system and the random terrain system, the height data injection enabled algorithm thing, remain non-altered. They are the same because this is a fusion of the simplified terrain system and the classic new terrain system, so clearly the classic simplified terrain system has to remain the same, on which also the random system is based, but that's another topic. Enjoy, and happy Christmas. Bye bye. This was Simon, also known as the Nerd of Algorithms. Bye.